pressure cooker has been widely used in the culinary arts community. In relation to a normal cooker, a pressure cooker takes a shorter time to cook and can make more meat tender. But why does it occur?
Pressure cooker versus normal cooker. So a person might wonder, how does a pressure cooker work? In a closed system or container, such as a pressure cooker, the water and vapor are in equilibrium, and it will maintain the same temperature. The vapor is just held above the surface of the water, which delays further evaporation of water, and it will lead into an increase of boiling point of the water. Since there is no place for the gas molecules to escape, when heat is applied to the closed container, the molecules in the gas state will increase its velocity, hence the temperature. This will now increase the pressure on the surface of the liquid as well as the temperature of the water system. Therefore, by cooking in a closed container, food can be cooked with much smaller amount of energy within a short period of time by minimizing the energy loss to the surroundings. How about normal cookers? Well, unlike the pressure cooker, when water is heated up in an open system, it will only be evaporated or the water will turn into gas. A higher amount of water will only increase the rate that liquid turns to vapor, but it will not increase the temperature of the liquid itself. If the pressure is decreased, such as at higher elevations, the point that water boils will be decreased since it is easier for water molecules to escape the surface. If the pressure is increased on water, it becomes more difficult for water molecules to escape the surface, and the higher temperature is required for the water to boil. The variables presented from the brief background of pressure cooker confirms the Gay-Lussac law. The French chemist Joseph-Louis Gay-Lussac discovered the relationship between pressure of a gas and its absolute temperature. Gay-Lussac's law states that the pressure and temperature will both increase and decrease simultaneously as long as the volume is held constant. From the knowledge we have obtained on how a pressure cooker works and how its components or variables relate to one another, we can now solve this problem. If the gas in the enclosed container, which is a pressure cooker, is pressurized from 10 atm to 12 atm, and its original temperature was 50 degrees Celsius, what would the final temperature of the gas be? So we all know the Gay-Lussac's law states that P1 over T1 is equivalent to P2 over T2. P1 and T1 are the initial values of pressure and temperature respectively, while P2 and T2 are the final values of pressure and temperature respectively. In the problem given, P1, T1, and P2 is given, but the temperature given is in Celsius. Therefore, we have to convert it first into Kelvin by adding 273 K. All we have to do now is to substitute the values. Afterwards, isolate T2 and calculate for its value. From the solution, the value we have obtained is 387.6 Kelvin.
So in the next time you're planning to cook a delicious meal and involves tenderizing meat, little preparation time, opt to use pressure cooker. That's it for today. Thank you for listening.